Good morning.
Good morning. Good morning. How's it going?
Good.
All
It's
right.
going.
All right. Cool, cool, cool. Wait for everybody to get all the way in here. All right. Looks like everybody's in. So, good morning, everyone. Hope all is well. Sorry for running a few minutes behind. I was actually in the wrong Zoom. I clicked the wrong link and I was sitting in one of my other classes. And I wonder where, why is anybody showing up? So, that was my fault. But good morning, everyone. Hope all is well. Hope you're ready to get this semester started. My name is Mr. Tucker. I will be your instructor for these 16 weeks. Um, Hopefully, you guys have been getting all of my emails. I sent 4 of them to your class. I know you gotten at least one of them because you got the Zoom information, right? So if ever, let's say you have been going a little while, haven't seen any emails from me, and you want to make sure that I haven't sent out anything, hold on. I will always archive my emails in Canvas announcements. So you're just talking about going to Canvas and hitting announcements. There will be, all the emails that I've sent out. So if you want to scan through your emails, then that'll be fine. But if you don't see anything, you can always go to Canvas announcements to see if I've sent out anything. Any email I send out, even if I just send an email and say hi, I mean, I wouldn't, but I'm just saying, any email I send out, I will archive them here in the Canvas announcement. So you have 2 spots where emails or communication will be sent to you guys. So the first emails, just greetings, telling you about the class, telling you how we will be operating. This is not, I mean, it's an online class, but we're not learning online. It's more like learning virtually. So what I mean by that is, if we say learning online, a lot of times that means I can send you a video, or you can learn, on your own time or something like that. Really, when you learn it virtually, it's the same thing as learning face to face. It's just that it's in a virtual world. So in other words, we'll meet normally at our regular class times. Bless you. Meet at, meet at your regular class time at 9:30 on Tuesdays and Thursdays. I'll be here. You guys will be here. I'll be writing on my virtual board, and you'll see it live. And we'll have an actual lecture. Um, and so that's the difference between, to me, in my mind, learning virtually versus learning online. Online, you can kind of be on your own a little bit, and but virtually, it's the same classroom experience. It's just that you're in your room and I'm in my room. So every class, every lecture will be recorded, unless it's like a soft. If we're doing like a review day, then I wouldn't really record that unless there's something there that really had content. Then I'll send it out. Normally, if we're just doing a review day, people are asking random questions, and it may only be. It just depends on what happens that day. So, but if it's something worth sending out, then I'll send it out. So anything I record, I do create a YouTube video for, and then create a link, and then I'll send that to you out, send that to you guys, so that if you do miss class, you will be able to go, check it out. You saw the Zoom information. That's why you guys are here today. So let's look at these 2 docs. These other 2 docs. Some of you have already done this, so that's cool. But if not, and you had any issues with it, here's the registration process for my math lab. Um, that's the computer component that we will be using to have access to all of our assignments, whether it be tests, homework, or whatever. You would just go to mymathlab.com, and we'll do that in a few minutes as well. Click on register now. You guys had a different course ID. This is just a generic email I pulled up, generic document. It's Tucker, if you haven't seen it yet, 21769. But it's, once again, I've already sent that to you, but it's just not, don't do 75660, because that's not your course ID. But anyway, you put in your course ID, and then you have 3 options. One is to input the access code, whether you've gotten it from, whether it's Barnes and Nobles, could have bought it from a friend, Amazon, whatever the case may be. You bought it from an outside source. It'll be like a 16-digit access code. You'll type that in, and then you'll have full access. You can purchase access from Pearson itself, in which they would not give you a code. They would just give you access, because you won't need a code, right? Because you're right there. And then if you didn't have the code, weren't ready to purchase the code, you can use a 14-day free pass, in which they give you 14 days full access for free. And then after that, it will ask you to pay. If you're not ready to pay yet, then they will lock you out. You will not lose any of your progress, and you will not lose, any of your work or submissions. Just I will still be able to see it. It's just that you won't be able to see it until you pay for full access. Sorry about that alarm. Questions on that? Everybody good? Okay. All right, the other one was details on how we will be using MATLAB. Hold on 1 second. Sorry about that. Just being transparent. My daughter came, sat on the couch, didn't start bouncing, and that was the dance. I'm like, go use the bathroom. So, yeah, the joys of being at home while you're trying to teach. So yeah, so you cannot pass the course without access to MATLAB, right? You have to have it because that's where all of your assignments, all of your tests, everything that we do will be generated and done through MATLAB. You must participate and show activity weekly. That's how I will solidify your attendance. So I will look at attendance through Zoom, but what solidifies your attendance, what gives you a timestamp is your activity in MATLAB. Let's say if you do miss class and you check out the lecture, well, to me, that's the same thing as sitting in class. You sat through the lecture, but I wouldn't know it if you were to do it through YouTube. So the best way to, have a physical timestamp on your attendance is to do something in MATLAB, even if it's nothing more than going in there, saving, going to a homework, saving it, and coming on out. If you haven't gone to class today, you at least want to come to class that week. You at least want to do something like that so your attendance can be, covered. When it comes to homework, you will have unlimited attempts to get the best grade possible in your homework. Homework, you're expected to get 75 or better. So for this class, developmental, so yeah, it's just a 75 or better. Really, I think it's 80 for you guys, but 75 or better on your homework. 85 if you want to get that 100% though. Go ahead and shoot for at least 85, and that'll give you full credit for your homeworks. Test reviews are not mandatory. But if you score 85 or better now, let me see. Can I do that because it's that developmental course? Yeah, if you score 85 or better, then I can add 5 points to your test. Now, once again, they're not mandatory. If you don't do them, there's no penalty. But your test for this developmental class, you have to score at least a 75 on all of your tests because it's the developmental course. They are looking for a level of mastery. So 75 on all of your tests has to be done in order for you to get your passing grade out of this class. I didn't put that on this because this was generic to all of my classes, but 75 on all of your tests is what you will be shooting for. You actually have unlimited tries to do that as well, but just keep in mind you don't have unlimited amount of time to do it. So you do want to make sure that you knock that out first, second shot. But if you need another attempt, you can get the other attempt. It's just that after that second shot, then what you want to do is get with me on unlocking it. So before I unlock it, I'll ask you questions and make sure you're good on taking the attempt because you don't want to do it 4, 5, 6, 7 times. Not saying that you will have to, but you just want to throw that out there. Your mindset should be, knock it out by the second shot. But if you're having issues, then that's most definitely you want to make sure you get with me so we can make sure you're straight. And the 2 attempts thing, that has nothing to do with you. Like I just told you, this is the developmental course. You get as many attempts as possible. It's just that, like I said, you don't want to do it past 2 attempts if you don't have to. Then any scratch work for your test, you want to go ahead and shoot that to me in an email, whether it be scanning or taking a picture or something of that nature. All right, questions on anything I've said here? Good, straight. All right. So let's go to MATLAB, make sure we are good. guess I could take it up here. All right, so register as a student, hit OK. Here's where you put in that course ID, Tucker 21769. And so you see the course right here, MD 60. And then create your account. If you already have an account with Pearson, maybe from a previous class, feel free to go ahead and use that. If not, create the account, put in your information. That's when it will ask you for the 3 options to put in the course, the access code, purchase access, or if you want to use the 14-day free pass, it will be in blue lettering, a blue letter link somewhere down here at the bottom of the screen to use the 14-day free pass. All right. Okay, so once you're in there, this should be the course. I thought I put the syllabus in here. Oh, well, I need to post the syllabus. Normally, that's weird. Download. Oh, I think it's because I have to download another shell. That's right. Okay. So I forgot I had to download another shell. I'll put the syllabus. Syllabus will be right up in here. Probably right under announcements or right before announcements, but I'll put that in there. So here go all of your homeworks. So you guys have a review quiz that will help you get ready for the test. The main thing are though that you need to take care of are your homeworks. Remember, 75 or better. And then I will post your test. Let's get in here. Yep. So here you go, test, post test. This shell didn't even have a test posted for the first test, so I had to create that. But anyway, the first test should be right here. I don't know why this funky new shell. Anyway, so that's how you do it. You can go right here and change your assignments. You know, that'll just be homework, or if you want to view all of your assignments, hit all assignments, and you can see all of them. All right. And I will also post test reviews. Like I said, those will be not mandatory. Those will be optional. But if you want to get extra work heading into the test, that would be very similar to your test, then that will be there as well for you to practice on. Like I said, I created this new shell, didn't bring everything over for some reason. So I have to go in there and post some things, but that's all good. All right, so looking at your assignments, let's show you what it looked like on the inside. Oh, okay, I see. So it wasn't posted. Okay, I'll check that later. All right, so this is what your assignment should look like initially. Now here, there's a video. You notice you can't click on any of your questions. Some of them have videos in front of the questions. You can look at it. You don't necessarily have to look at it. You sat through a lecture with me, so it's up to you. So if you want to, you can just click on it and then close it out, and then that'll give you access to your questions. But feel free, to look at it if you like. But I didn't make it mandatory that you have to look at it, because like I said, if you sat through the lecture with me, then hopefully you're good to go. And this one is just dragging, so that's not one, that's just like vocabulary. So I want to show you a real problem though. Let's do this one. So I'm just throwing an answer in there. Notice it says check your answer. It was wrong, but it tries to give you a hint. Check your answer again, tries to give you another hint. And notice now it says final check. So it'll give you 3 chances to get the answer correct. If you get it wrong, you can go to the next question or hit similar question. You hit similar question, that will reset the problem. If you don't hit it, then you can still hit it right here. So if you hit it, then that resets the problem. Very similar problem, just change the numbers. If you go here, you see as you have a red X beside that question. Once you get it right, it turns into a green check. help me solve this is a tool down here. Normally you don't do that one unless you're really done with the problem, you can't figure it out, you just need help with that problem, because once they walk you through it, then they'll reset the problem again. So most people don't click on that, but it will give you step by step. You can walk, they'll walk you through the problem. Most people like to do view an example, because here it'll open up a window of a different problem very similar to it and walk you step by step through that one. A lot of people like to print it as well. Then when you close it out, then you'll have access to the problem you're working on. If you need more help, sometimes they have a video, another video, depending on the complexity of the problem. Now, keep in mind, this one had a video in front anyway, so that's probably why the video is not in here. But if you click on textbook, it'll take you to the place in the e-text where the problem is discussed. Ask My Instructor will actually send me an email that you had a problem with this problem. Sometimes that can be a little sketchy, though. I know in the past I've had people say they shot me an email through Ask My Instructor and it didn't get to me. They could have done something wrong, or it just could have been, problem with interfacing with technology. But if you do shoot me an email through Ask My Instructor and for some reason I don't get it, always feel free to email me the traditional way, TCC email, or through Canvas. I get those. And then some people like to print them, so you have that option as well. All right, now notice on these definition ones, you only get one answer. That's because once you hit it, they give you the answer. So really, when you go back to it, all you have to do is put the answer there that they just gave you. So that's the only thing about the definition ones. You only get one shot, but you can go back. All you do is reset the problem. Notice it says try again, and then you get to reset it again. So it's still unlimited amount of tries with any problem that you get. All right, questions on anything? Is everybody okay?
Yeah, how do we show work?
You have to show it on your own paper, and then you would have to email it to me. Yeah.
Okay.
Yeah. So now for homework, I don't ask for that. I only ask for that for your test. To do it on your scratch paper, then shoot me whether it be scanning, take a picture of it with your phone, whatever way. That's how I'll be doing. All right. Good question. Good question. Anything else before we go to anything else? Everybody good? All right. I believe that's it for as far as the introduction is concerned. If you ever have any issues or concerns, always feel free to email me. If we need to set up a time outside of class, email me and we can match up our schedules. Setting up Zoom and not Zoom office, Zoom hours with office hours. To me, I just felt like the best way, and that's what's worked so far, is just you email me and let's see what schedules match up. Yeah, I mean, sometimes I've done it on Saturday morning, because if I was setting up office hours, I would not do a Saturday morning. You know what I mean? So it just depends on schedules and matching up stuff. Friday evening, Thursday. Sometimes it's just these weird hours with people, and their schedules actually match. So in order to cut out that these are my office hours, and then you never hit me up because no office hours match yours. Just email me and then we can match up what works for both of us. All right, and there also should be times where we can meet during class or after class lecture as well. I don't ever plan on lecturing every single class all the way to what class ends at 11, I believe. Yeah, 10:45. For the most part, I'm not going to do that every single class. If I do that in either class, because we're trying to make up for lost time or making sure that we get this concept straight, or it was a lot of questions. So there will be opportunities for you to ask questions during class as well. All right. Anything before we go ahead and at least talk about one section today? Everybody good? Okay. So let's go to the notes. All right, so we're looking at 3.3, solving linear equations. Hold on, check one more thing out of this shell. Okay. All right, so solving linear equations. So an equation is just a statement that says that two algebraic expressions are equal. All right, and a simple example of that is x plus 5 equal to 8. All right, and also I cannot see most of you, and that's fine. You don't have to enable your camera, during lecture times. Oh, I didn't talk about testing as well. Um, you don't have to enable your camera during lecture time. So if I do move a little fast and you're still copying, always feel free to either type in the chat or unmute and say, can you scroll back up? I was still copying the last bit, because if I can't see you writing, I won't know that you're still writing. So that's fine. But also when it comes to testing, um, there will be times when I set aside class times for us to test, but you are expected, if I don't set aside class time or haven't done so yet, you are expected to make arrangements with the testing center. And I will give you Mr. Davis' email. I just write it right here. Oh, go blue. Mr. Johnny Davis. And it's J.L. Davis at tcc.edu. So when you're ready to take a test, and let's say there hasn't been a time set aside for us to do so. This is really where you're expected to do it anyway with the Mr. Davis, but I will, find time, at some point to at least give you a day here or there to take a test, but you're supposed to do your testing on your time. Like, let's say if this was the class time, we were doing face-to-face. You would just go to Mr. Davis, which would be right across the hall from our class, and just set up a time to meet with Mr. Davis and take the test there. So, yep, that's how we'll do it. And that saves on lecture time. And that gives us as much time as possible to make sure we get through this content without trying to rush and everything. And then what's going to happen is that everybody's going to be in a different spot, once they start working on their work and everything like that. And you may be ready to take the test, but the class as a whole may not be ready. It just, it makes the class lecture a little easier. Since I'm living abroad, we don't have online proctoring available. Yeah. That's what you would do. That's why you would contact Mr. Davis. Like, nobody's going in, nobody's being made to go in. You'll contact Mr. Davis and they will set up a time for you to do the online proctoring. Yep. So I was just saying that if we were face to face, you would go across the hall. But no, you email Mr. Davis and they will set that up. Yep, not a problem. So you say you're abroad, you're living abroad. Where are you, if you don't mind me asking?
I'm actually living in Germany.
Wow, okay, cool. That's awesome.
Yeah.
Yeah, I want to do. I've never been out of the country, so I
I
do
would
want to.
recommend it.
Yeah, everybody says that. I need to do it one day. Let me look. I'll be over here talking all day about that because let me stop. So, pretty sure you guys don't want to hear about my shortcomings of not traveling. Um, but yeah, um, solution. We want to go ahead and get into a solution that's going to be a value of values that will make an equation true. So in other words, for this problem, we have x plus 5 equal to 8. What you want to ask yourself when it comes to any equation, when is this equation true, or when is x plus 5 equal to 8? And our answer in this case is when x is equal to 3. And you can always plug in your equation or your solution into your original equation to see if it creates a true statement. So in other words, if I were to plug in 3 right here, 3 plus 5 is equal to 8. And so that's how you will be able to check your solutions. You can always go back and plug them into the original equation to make sure that it is true. Trying to make sure nobody else trying to log on. Okay. Scroll up a little. So we will be solving by what I call opposite operations, the operations that undo what the other one is doing. So addition and subtraction, opposite operations, multiplication and division, opposite operations. All right, let me erase this. All right, so going back to the x plus 5 equal to 8. All right, so we want to get the variable by itself. We want to have, when we solve, x equals 2. So your goal is to get your variable by itself. You want to undo what's being done to your variable. So if I'm adding 5 to my variable, I need to subtract 5. Now, the other important part of the relationship between your equations is you want to recognize where is your equal sign, because that will set up your equivalency. In other words, to the left of my equal sign, that's the left side of my equation. To the right side of my equal sign, that's the right side of my equation. And whatever you do to the left side of your equation, you have to do to the right in order to keep your equivalency. So if I'm going to subtract 5 from one side, I have to subtract 5 from the other side. And that only comes into play when I'm dealing with these opposite operations. So the 5 and the negative 5 will cancel on the left, leaving me with just x. And then 8 minus 5 is 3. And that is my solution. And so that's going to be the foundation of solving equations. Your goal is to get your variable by itself and to simplify what's on the other side of the equation. You will use opposite operations in order to get your variable by itself. And then whatever you do to one side of your equation or one side of your equal sign, you have to do to the other in order to keep your equivalency. So I have a few more one-step equations before we add more to it. So I'm going to walk through it. So y minus 10 equal to 15. You want to get y by itself. So you're going to add 10 to both sides. 10's cancel. 15 plus 10 is 25. Next one, we have 5a equal to 13. 5a means 5 times a, so that means we need to divide to undo the multiplication. Cancel out a 5. 5 divided by 5 is just 1. And don't forget, 1a is the same thing as a, just like 1x is the same thing as x. They assume, if you just see that variable, then there's a 1 in front of it. So that means if I had 2x plus x, that's going to be 3x. So normally having a 1 in front is not what they do. They assume that if you have that variable, then a 1 is sitting in front of it. So just throwing that out there. So 13 over 5 is what we have as a solution. Now, you do not have to convert that to a decimal or a mixed number. They assume you are pros at doing that type of thing now. So converting to a decimal, converting to a mixed number is not necessary. But they are expecting you to reduce if possible. So here, let's say an example, if you have 4 over 6, they have a 2 that's in common. The 4 and 6 have a 2 in common. And so you cancel out the 2's and that leaves you with 2 over 3. This is what you are expected to do. They're not going to tell you, but they do expect you to write that in simplest form. So in my math lab, if you were to put in 4 over 6 as an answer, then they will either mark it wrong or tell you that this is not the simplest form or the answer is not in lowest form or something along those lines. Looking at this 13 over 5, there's nothing we could do to it. So the answer is just 13 over 5. So just throwing it out there. If you were to put in 2 3/5, it would not mark it wrong, but you're adding a step to your process. Don't forget you're human. So the more steps you add to your process, the more steps or the more opportunities you're giving yourself to getting it wrong. Because if you had 13 over 5 in your notes, because in your scratch work, but then you put 2 1/5, well, that's wrong. And they'll mark that wrong. You know what I mean? So if they say you can leave it as 13 over 5, you might as well just stay there and just roll on to the next problem. So just throwing it out there. Any questions on that before we look at the last one step problem? All right. So x over 9 equal to 11. That's x divided by 9. So we'll multiply both sides by 9. 9's cancel, leaving you with just x. And then 11 times 9 is 99. So once again, those are, foundational types of problems. We're going to add another step to it. But any questions before we look at another one? All right, so here we have 2x plus 1 equal to 17. So we have two operations being applied to our variable this time. We have 2 times x and then plus 1. So we need to move that 2 and the 1 to the other side of the equation. But remember, the only way we can do that is through opposite operations, undoing what's being done to x. Now, we could divide by 2 in both sides, but we're now creating fractions unnecessarily. So you don't want to do that if you don't have to. So the best practice or the most efficient way to solve this is to first subtract 1 from both sides of your equation. Ones cancel. That leaves you at 2x equal to 16. And then from there, we can divide both sides by 2. And our solution would be 8. All right. All right, next one. 3a minus 6 equal to a plus 4. So notice this time we have 2 terms that have a, the variable a in them, and they're on other sides of the equal sign. So if that's the case, your goal now should be to get all of your terms with a to one side of the equation, all of your terms without a to the other side. Now we have 4 different terms here. It doesn't matter which one you decide to move first and what side you take it to, as long as you stay correct with your mathematics, you still get the same answer. So what I decided to do first was to subtract a from both sides. And don't forget that is 1a. So I subtract the a from both sides. That cancels out on the right. And then on the left, 3a minus 1a is just 2a. So it's 2a minus 6 equal to 4. Now I would add 6. 6 is canceled. That leaves me with 2a equal to 10. And then divide by 2. And a is equal to 5. Any questions? All right. All right, next one. 17 minus 7x plus 3 equal to negative 3x plus 21 minus 3x. So notice we have like terms on each side of our equal sign. What I would do is simplify as much as possible on each side of our equal sign first before I actually move stuff across the equal sign. Now, you don't necessarily have to. You can just start moving stuff around if you want. But just remember, if you're moving stuff across the equal sign, you have to use opposite operations. If I'm staying on the same side, I just combine them as is. So when I look at this first, did my eraser wrong? When I look at this first left side, let me see, I look at the left side of my equation. I can add 17 and the 3 together, and that'll give me 20. Once again, if I'm staying on the same side of my equal sign, I don't do opposite operation. I just combine them as is. You only do opposite operations when you're going to move across that equal sign. All right. And then on this right side, I'm combining the 3, negative 3 and the negative 3, which will give me negative 6x. Let me see if I want to put that back. I guess. So my equation now is 20 minus 7x equal to negative 6x plus 21. So before we go any further, questions on what we've done up to this point? So now, once again, we have our variable in more than one place and they're on different sides of the equation. So we need to get all of our terms with x on one side, all of our terms without x to the other. I decided to add 6x to both sides. Once again, you could have moved the 20 first, or you could have took the 7x over, brought the 21 over. It doesn't matter as long as you do everything correctly. Eventually, it would all come out to give you the same answer. Oh, crossed out the wrong one. So my 6x's will cancel. And then on the right, not right, but on the left, I have 20 minus x equal to 21. All right. So now we can subtract 20 from both sides. And I'll put that arrow there in front of x, in front of that negative to make sure we hold on to the negative. So make sure you don't lose it. That's still minus x or negative x. And then 21 minus 20 is positive 1. But we're trying to solve for x and not negative x, so we need to take the negative over. So that'll give us x is equal to negative 1. Any questions before we do another one?
No, sir.
Okay, sounds good. Thank you. All right, let's look at another one. 7 times x minus 2, the quantity of x minus 2 equal to 9x minus 6. So the first thing we'll do here is distribute the 7. And that'll give us 7x minus 14 equal to 9x minus 6. And we're back at this place that we were in the last problem where we have our x in different terms, different sides of the equal sign. Now we want to get all of our terms with x on one side, all of our terms without x to the other. So I decided this time to add 14 to both sides. First. All right. So that will give us 7x equal to 9x plus 14. Now I want to get my 9x over there to the left. So I'll subtract 9x. So it'll give me negative 2x equal to 8. And then finish it off by dividing by negative 2. And that'll be negative 4. All right, any questions?
No, sir.
Okay, thank you. So now the next section is solving. I'm just flow into it. This section 4.8 is solving equations with fractions. Normally all of it is one section, but they broke it up in your homework. All right, solving equations with fractions, that's 4.8. So let me check out one thing. We go up here to this one. No, this is not the time. Let me see if there's somebody I have to answer. Give me 1 second, guys. I'm sorry. Okay. All right. So sorry about that. All right. So solving equations with fractions. We'll do a couple of these. See how many I got going on right here. Yeah, just a few problems and then we'll be done for today. Okay. All right. So solving equations with fractions. So one way you can do it is dealing with the problems with the fractions involved. So when adding subtracting fractions, don't forget you have to have common denominators. So if this was a problem that just had, this, if it was just x minus 3 equal to 1, first thing we would do is add 3 to both sides. So we follow the same process. Don't let the fact that you have fractions, scare you off. You follow the same process, and that's what we did here. You just add 3/4 to both sides. So I have 1 over 20 plus 3 over 4 on the right because they do cancel out here on the left. And like I said, right here in the purple, don't forget when you add and subtract a fraction, you have to have your common denominator. So you want to find your LCD or at least a common denominator. Sometimes LCD, you may not see it, but at least you want to find a common denominator. That's the smallest number that each one of those numbers can divide into evenly. So when you look at the 20 and the 4, what's the smallest number that both 20 and 4 can divide into evenly? All right. Let's say, can we go back up? I don't know how far up you want me to go. So when I go up, let me know. Is that good enough? Okay, cool. All right, so LCD is the smallest number that each one of them can divide into evenly. So 20 can divide into itself, and then 4 can also divide into 20 as well. So your LCD would be 20. If you didn't see it and you just multiply 4 times 20 and had 80, that's fine. It's just that you're going to be dealing with very, very, way larger numbers than you necessarily have to. So it wouldn't be any worst thing in the world to just multiply 4 times 20 to have a common denominator. It just wouldn't necessarily be the least common denominator. So 1 over 20 doesn't change because we want to have that denominator to be 20. And then what do you multiply 4 to in order to turn that into that least common denominator 20? And that is 5. And then when it comes to fractions, whatever you do to the bottom, you have to do to the top. And that's what we did right there. 3 times 5, 4 times 5, that gave me 15 over 20. Adding those together, 16 over 20 is our answer. So then from there, if you can reduce, you are expected to do so. So there's a 4 that's in the 16 and in 20, 4 times 4, 4 times 5, 4 is canceled. And our most simplified answer is 4/5. All right. Any questions? Any questions? Everybody good? I scroll up.
Thank you.
Thank you, sir. If I scroll up too far, let me know. Like I said, trying to make sure everybody have a chance to write. Okay, so the next one, 3/5 A equal to 9. If you have a scenario like this, and you just, your goal is always to just solve for A. You have 3/5 times A. That means you would divide by 3/5. Well, if ever you're dividing by a fraction, you're multiplying by the reciprocal. So really, all you have to do is multiply both sides by the reciprocal. And reciprocal just means to flip that fraction. So if you have 2/3, then flipping that fraction is 3/2. So I would multiply both sides by 5/3. So that's what I did right here. Multiply both sides by 5/3. All right, so when you look at what's going on right here, multiplying by the reciprocal, if you just multiply across, 5 times 3, 3 times 5 is 15/15, which is just 1. Or you can cancel them out. 5/5 cancels. 3/3 cancels. And so that leaves you just 1. Now, when you look at 5/3 times 9, you can handle it one of 2 ways. And I'll show you both ways right here. This is the first way, when you can cancel out the 3 into the 9. That leaves you with 3. And then 3 times 5 will give you 15. Or if you just multiply across, 9 times 5 is 45. 3 times 1 is 3. So 45 divided by 3 is 15. So either way, you'll get 15. It just depends on which way you're used to dealing with your fractions. I would always suggest look into make sure you're mastering how to cancel out before you multiply, because that will ensure that you're dealing with smaller numbers when you do your multiplication. All right. So questions on what we did there as far as solving?
No, sir.
All right. Oh, trying to look for something. All right. So the other way we can deal with fractions is we can clear them out. So we have x over 6 plus 1 equal to 4/3. First thing you would do is find your LCD. In this case, our LCD is 6 because we're looking at 6 and 3. What's the smallest number that both 6 and 3 can divide into evenly? And that would be 6. Then you're going to multiply each numerator by the LCD. So notice we didn't do top and bottom. We multiply each numerator by the LCD. And notice also even the 1. So a lot of times what people will do is just multiply the fractions by the LCD. No, we need to multiply every single term. If you don't do that, you will change the value of the equation. So everything needs to be affected by the LCD. So we multiply each numerator by the LCDs. And then we will simplify. All right.
No questions, sir.
All right, thank you, sir. So the 6's will cancel in the first one, leave you with just x. 6 times 1 is 6. And then here, 3 cancels into 6, leave you with 2. 2 times 4 is 8. So now we have a regular equation. X plus 6 equal to 8. And then last step, we can go ahead and solve. Subtract 6 from both sides, and that'll be 2. All right. Any problems? Any problems?
No, sir.
All right. I'm still copying. Okay, we'll do another one like this. Run through the process again. We have y over 4 equal to y over 12 plus 2 over 3. Find your LCD. In this case, it'll be 12. Smallest number to both. Not both, but each can divide into evenly. We have 4, 12, and 3. So 12 would be the LCD. Step 2 is to multiply each numerator by 12. Step 3, we're going to reduce. 4 goes into 12, leaves you with 3. 12 into 12, it's 1y. 3 into 12 leave you with 4, and then 4 times 2 will give you that 8. So now we have 3y equal to y plus 8.
No questions?
Thank you, sir. So then from here, we want to get our y terms on the same side. So we'll subtract y from both sides. Cancels out on the right. On the left, we have 2y. So that'd be 2y equal to 8. Then dividing by 2, y is equal to 4. Got 2 more examples, then we'll be done. 2 more quick examples. You'll see why they call it quick, in a second, but then we'll be done for today. Everybody good? Scroll up. Everybody all right? All right. So next two are similar. Let's not going back up. There you go. We have 2 times the quantity of x plus 1 equal to 2x plus 3. First thing we'll do is distribute the 2. And that will give us 2x plus 2 equal to 2x plus 3. Now our next move is to get all of our terms of x on one side, all of our terms of x to the other. So that should be our thought process. So if I were to subtract 2x from both sides, don't be afraid to let math happen. And what I mean by that is that we will cancel out 2x here. And sometimes people will do 2x minus x, and that'll leave us with x plus 3. But if 2x minus 2x cancels out over here, then 2x minus 2x need to cancel out on the right as well. So what we're left with is actually the variables cancel out completely, and it leaves us with a false statement. Now, if you decide to move the 2 first or move the 3 first, then you may have 0 equal to 1 or -1 equal to 0, and that's fine. Either way, it's a false statement. We're not getting caught up on what the numbers are. We're getting caught up on the fact that our variables cancel and we had a false statement, because 2 is not equal to 3, right? So if our variables cancel and we have a false statement, then our answer is no solution. There's no number that we can plug in for x that will give us a true statement. So if your variables cancel and you end up with a false statement, remember, once again, it's not the fact that you ended up with 2 equal to 3. It's just that you ended up with the false statement that 2 is equal to 3. And that means you will have no solution for an answer. All right. And also, don't write false statement as your answer. No solution is the answer. So make sure that's more clear. All right, questions on that one? Look at the next one. All right. Next one, 4x plus 6 equal to 6 times x plus 1 minus 2. distribute the 6x plus 6 minus 2x. Combine your like terms of 6x and negative 2x. And that will be 4x. So we have 4x plus 6 equal to 4x plus 6. Minus the 4x on both sides. And we have 6 equal to 6. Or in this case, you could have had 0 equal to 0. But the bottom line is you have a true statement. 6 is equal to 6 or 0 is equal to 0. And so when your variables cancel.
So
Mhm.
if it doesn't have an x, do the numbers have to be the same?
Yes. Now, what don't have to, well, if you want to, if your outcome is all real numbers, they would have had to have been the same. Right.
Okay.
So 1 equal to 1, 2 equal to 2, 0 equal to 0. Yep.
Okay.
So if your variables cancel and like you just mentioned, and the numbers are the same, which is a true statement, then your answer will be all real numbers. Yep.
Thank you.
Not a problem. So the previous problem, if you have no solution, that means no values for x will be a solution. In this case, no matter what you plug in for x, it will be a solution. You can plug in anything. All right. Any questions on anything? Anybody? So those are your first 2 sections. Normally they run together as one section, but this class breaks it up into 2 so that you can look at the homework, and section it off. Anybody have any questions on anything before we close?
No, sir.
All right, thank you, thank you. Anybody else? Anybody else? All right. So, see something in the chat. Okay, cool. So, first day of a great semester. Let's go ahead and get this thing rolling. Get into your homework. See if you actually have questions, because sometimes questions don't come up until you actually get into the homework and start doing things, and that's understandable as well. So get in there, see what you got. If you have any questions, you can wait till next class or shoot me an email. Also keep in mind that you can move ahead if you really feeling it and you're rolling. Feel free to do so. You don't have to wait for the class. You don't have to wait for the class in order to be able to take a test. Remember, I just gave you Mr. Davis' information. You don't have to wait for the class to ask me a question about a class, topics that are ahead. If you wait until after class, after the lecture, and you ask me a question about something in chapter 5, I mean, that's where you are. That's where you are. I will answer any questions that you have. Somebody asked for the class code. Course, are you talking about the code or course ID? Because the access code is something you purchased. Course ID is what I sent to you in the email. All right, wait for you to answer. So, but for everybody else, that's it for today. I'll wait for your classmate to answer that for me, and then I'll go ahead and log off. But other than that, you guys have a good one. Be safe. Excuse me, be safe, and I will see you on Thursday. All right, take care. Have a good one. Have a good one. 217.
I actually have a quick question.
Mm-hmm.
So for when you buy the access code, it only lasts, you said 14 days?
No, that's a 14-day free pass. You don't need anything for that.
Okay.
Yeah, when you buy the code, you got it for the whole semester.
Okay, and you buy the code where? You said Barnes and...
You can either go to TCC's bookstore, Barnes and Noble bookstore, or you can buy it through Pearson itself. When you go to register, they'll give you the opportunity to purchase access.
Okay, thank you.
Now I'll say this, if you purchase access through Pearson, they won't give you a code. They'll just give you access. Yeah.
Okay.
All right. Anybody else before we close out? Everybody good? Yeah, everybody has to make an account. You'll create an account when you do your registration. All right, you do the same.